the session. So I'll be asking some questions. All right, so this is scientific method and experimental design, kind of a recap or an overview of it before you start this assignment. So on the board here, I have on the board behind me, if you can see it, no glare. It's kind of hard to see. Let me see if I can get the glare going. Oh, the glare is still there. Okay, so guys, I have a picture of a window seal with 3 pots. All right, and I have 3 plants growing in that particular pot. The same soil, the same plant type, the same access to sunlight. So my question for you is, the independent variable here is the thing the scientist changes. Now that delta symbol, that little triangle, is the symbol for change in science. So the delta symbol means change in. So independent variable is the thing the scientist changes in the experiment. The dependent variable is the thing we're going to measure. So it's the change that occurs because of what you as the scientist change. All right, Waylon, you ready?
Yeah.
So here's my question for you. So in this experiment where I have 3, Jalen?
Yep.
So I have 3 identical plants, 3 identical pots, 3 soils the same, their access to the same sunlight. The only thing that's different in this particular experiment is one gets 5 milliliters of water, one gets 10, one gets 20. Okay? So what in this experiment is the independent variable, the thing the scientist is changing? What do you think, sir?
The water.
So the water, the quantity of water given to each one, right? So as a result of giving them different water levels, what is the change that I'm going to measure? Yes, sir.
I mean, like the growth of the plants.
So the growth of the plant. So I have this little tiny meter stick right here, right? And that meter stick, over a course of a month's time, I'm going to see how much it grows. Now, we did this experiment back about 5 years ago when I first started here, when I was over in Coach Carroll's class. And I used to drink a lot of NOS, a ton of NOS, like seriously 2 or 3 cans a day. And I couldn't run from here to that door without my heart rate going through the roof. So I was either change my habits or my diet at 30 years old or whatever. So I stopped drinking it. I haven't drank any for about 7 months. But because I drank so much NOS, my students during that course of that year, when we had a science experiment, we had a science fair and they got to choose what experiments they wanted to do. One of the groups wanted to test this experiment, but instead of water, they did NOS, vinegar, milk, and water. So they watered those plants the exact same amount of each day over the course of a whole month. And so they then checked the growth, their dependent variable, they checked the growth of those plants at the end. And what do you think they found? Which one do you think grew the most?
Water.
Water grew the most? What do you think NOS did?
Maybe killed it.
It didn't kill it. It actually did really well. Think about you, and if I give you NOS and then let you sit for a couple of minutes and then tell you to exercise, what's your heart rate doing?
What's going on?
So there's a lot of sugars inside that. So the plant really metabolized that sugar, and it grew pretty well. It didn't grow as well as the water, but it had the second highest growth rate. What do you think had the worst growth rate? The vinegar almost shriveled the plant up and died because it's an acid. So it like really ate the plant up from the inside. And then milk was just kind of stagnant or whatever. But it was a good experiment, right? So, and they come up with it on their own. So very cool. So I'm gonna give you another one real quick. So last year, I don't know if you guys did it with Coach Carroll, but we had a water bottle experiment, right? Remember that one?
Yes.
All right, so we had a water bottle experiment, and I had some water in this container, and I had a hole at the 10 centimeters, a hole at the 20 centimeters, and a hole at the 30 centimeter mark. So I'm not going to answer any questions this time. I want you to do it. So Addison, what is my constants, the things that are the same in this experiment? So if everybody had their own water bottles, what is the same thing?
Where the holes are? Where the holes are.
So so in every bottle, all the holes are in the same spot on every bottle. Yes. All right. So give me another constant, Jalen. Give me another thing that's the same in the water.
I guess I probably have the same water bottle.
Same water bottle. So I didn't give them different heights, right? I gave them all that water bottle right there. So can you hold that water bottle up so they can see it around there? Pick it up. So I gave them all that water bottle right there. Everybody has that one. Okay. What's another? It's another same thing. What's inside the water bottle? Same amount of water. So I didn't start them off with a little bit of water and then another group, another little. They all stayed the same. So I kept everything constant. Yes, sir. So they stayed the same. So because those are the constants, what's my independent variable in this? What are the things that the scientist is changing through this whole process? What are the scientists changing in this process? Huh?
Putting the holes in it.
Not just putting the holes in it, but what? Where the hole is at, right? So not just putting the holes in it, because I'm putting holes in all of them. So that's a constant. But where the holes are at. One time I'm going to check it at the 10, one time I'm going to check it at the 20, and one time I'm going to check it at the 30, right, Waylon? All right, so Waylon, because I changed the hole position, what is my dependent variable? The things that I'm measuring. So in this particular question, the original question, I said, what is my question was, which hole has the fastest rate of flow? The 10, the 20, or the 30. So what is my dependent? What am I measuring? What is it?
The bigger one?
No. They're all the same size hole.
Oh, okay.
All the same size hole. What am I measuring?
I don't know. I wasn't paying attention.
I know, that's why I called on you, right? So watch this. So I'm squirting out water, right? Each one of these holes are squirting out water into a container. So here's our container. It's capturing the water, right? So all of them are emptying. Which hole do you think would empty the fastest, Waylon? 10, 20, or the 30?
The 30.
So he thinks the 30. Anybody else have a different? Yes, sir?
10.
You did this. You better know the answer to this. Oh my gosh. So he's right. Why is he right?
Because there's more pressure on the water.
So right now, on every single person in this classroom, pushing down on every square inch of this bottle and every square inch of you is 14.7 pounds of pressure right now. It's called atmospheric pressure. So that's how you can also, when you feel a storm coming up, you can feel the storm coming up because you're used to 14.7 pounds. Here's an example of you feeling the pressure. If you've ever gone swimming and you dive deeper, what do you feel?
More pressure.
Where at?
In your ears.
So that airspace that's in your ears feels that pressure first. And you're like, oh, and you like hold your nose and do your jaw like that. Or if you're driving through the mountains and you're like, right? You feel that pressure. So when you drive over mountains, you're decreasing and increasing that pressure that's on you. If I go down 33 feet, for every 33 feet I go up or down, I get either added 14.7 pounds onto me or take away 14.7 pounds. Either or. All right. If I go up, pressure's taken away. If I go down, it's added. So if I go underwater and go deeper, right, I'm going down, I'm adding 14.7 pounds every 33 feet. Scuba divers have to know this. I'm a certified scuba diver, and the thing you have to know is when you go and you're diving, you're going to hit what they call another atmosphere. So if I'm diving, and here's the top of the ocean, here's the bottom of the ocean, every 33 feet, I'm going to have to fix my ear. That makes sense? Because I'm hitting a new atmosphere. Another 14.7 pounds is added to me. Make sense? All right. I know that's a little separate aside, but I like giving you guys knowledge. All right. So that's your